So I'm going to do an example here based on problem number 8 in section 7.2 of the homework. I also covered this in the sets and Venn diagrams document in week 9 documents. There's various problems in the homework and in the quizzes that you'll see. So I'm just going to do an example. So when I pulled up the problem, we have this graphic. We've got the three sets within the universe all intersecting, and the task is to find how many elements are in each of the various subsets of the universe. And we have this information over here. The number of elements in A intersection B is 14. The number of elements in the intersection A, intersection B, intersection C is 7, etc., etc. So what we're going to do is figure out how to determine how many elements are in each of these 8 specific areas of the universe. So an easy way to do this I've found, when I'm sitting at home doing these on the weekend with the family, finding this spot right in here in the middle, the intersection of all three, helps to determine these other 3 regions. And then once we find these regions, that helps us find those, etc. So this segment right here is the intersection of all 3 sets. So that's right here, the intersection of A, B, and C. And that contains 7 elements. All right, so we know one section now. That's 7. All right, so we've taken care of that one. Now what can we do? Well, if we look at this top one, A intersection B, that's this area right here. That's where A and B overlap. So the total in that overlap is 14. Well, we know that this overlap contains this section and this section. The total is 14. Well, we already have 7 here, so that means there must be 7 here. So now we know 2 of the subsets. So we know, so the intersection of A and B is 14, so that overlap is 14, in fact, 7 plus 7, and then in the middle there's 7. Now here we have the intersection of A and C, which is 11. Let's tackle that one next. So A and C, that overlap is right here, and that contains 11 elements in all. Well, we've got 7 here, so that means we're going to have 4 here. Okay, so total is 11. 4 plus 7 is 11. I know there's 7 in the middle, so to find how many are in here, I just subtract 7 from 11. Okay, so we've got that one. Now let's go down. B intersection C. That's this right here, the overlap of B and C. Well, that equals 7. Well, so the total of these 2 must be 7. That means in this space, we have no elements. So 7 plus 0 is 7. That's how much is in the overlap of B and C. And we know there's 7 in the middle. So there we go. We've got those done. Now we've got intersection of A and not C. So I want elements which are within set A but not part of set C. So these 4 elements are in A. The ones that are not in C are these 2. So this one we don't know, and this one including 7 elements. Those 2 are in A, but not in C. So if that total is 11, we're going to have 4 here. So it looks like our total in A is going to be 22. Taking care of that one. Now this next one says the number of elements that are in B but not C is 17. So here are the elements of B, these 4 sections. The ones that are in B but not C are these 2 right here, the 7 and this unknown one. So if the total is 17, 7 plus this must be 17, or this right in here, the ones that are in B only, that's going to be 10. Okay, so got that one taken care of. Number of elements in C is a total of 15, so here, 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 that total is 15, so we've got 4 plus 7, 11. To get to 15, it looks like we've got 4 here. And then the last one is not in A and not in B and not in C. That's this area outside of all the sets. And that should equal 7 according to our information here. So going back here, we have B has a total of 24, C has a total of 15, and outside of those 3 is 7. So we can go back and check A intersection B, that total overlap, yeah, 7 plus 7 is 14. The intersection of all 3 is 7. The intersection of A and C is 4 plus 7 or 11. The intersection of B and C is 7. 7 plus 0. A not C is the sum of these two. 4 plus 7 is 11. B and not C are these two. 17. C adds up. 4 plus 4 plus 7 plus 0 is 15. And on the outside is 7. So in our problem, let's see what we can do. I want to find the elements in each. So elements in region 1, it's right there. That should be 4. In region 2 should be 7. Region 3 up here should be 10. Region 4 right here should be 4. Region 5 is that middle intersection of all 3, 7. There are no elements here. Region 7, that's down here. And then on the outside, we'll have 7. So let's see what, see how we did here. Check answer. Excellent. Okay. So that's how you work one of those. Again, starting from the middle, if you have that information, is best, and then working your way out is often the best way to go.